Welcome to Ask and Learn.
So in this question, we're using capacitors and as memory cells. So it's like qubits where we have a charged capacitor is a 1 and a charged one with a 0. So we can use these kind of capacitors on a chip so that in a computer. So we can fabricate them so that they have a capacitance of 1030 femto-farads. That's a very small number. Okay, so we have 3 times 10 to the negative 14 farad, tiny capacitor. And then we have K equals 25. We want them to be tiny, so the higher the constant, the smaller they can be. And then we want a dielectric strength of 10 to the 9 volts per meter. So the question is, if we want the operating voltage to be 1.5 volt, how many electrons would be stored on one of these capacitors when charged? Okay. So if V equals 1.5 volt, we want to know how many electrons. So let's first find out the amount of charge on it. The total amount of charge is capacitance voltage. Okay, so the capacitance we already know. It's this tiny thing. 3 times 10 to the negative 14 times voltage is 1.5 volt. If we want to figure out how many electrons, so we can divide C by the charge of an electron. 1.6 times to negative 19, and this is going to 2.8 times 10 to 5. Okay, so that's how many electrons we'll have. We want them to operate at 5 volt. And then question B asks, okay, so how thin a dielectric layer could we use? We want to operate at 1.5 volt. So what that is saying is that, let's look at it. We have this electric field this much, and we already have the dielectric constant of 20. So it's easy to find D. D is voltage times electric field. Yeah, we actually do not need the dielectric constant in this case. So voltage is 1.5 volts, the electric field, or dielectric strength, whatever the word is, 10 to the 9 voltage per meter. And so 1.5 nanometer. Okay, and then it says, using the layer thickness of my answer to part B, okay, so it's 1.5 nanometer, what would be the area of the capacitor plate? Oh, okay. I mean, we already know what the capacitance is, and we know this distance, the dielectric. We're like working backwards because we know equals epsilon naught A over D. Okay, so we're looking for A into all the other numbers. That's C times D over K times epsilon. Alright, so we can plug in all those numbers. And this is just 3 times 10 to the negative 14 farad times 1.5 times 10 to the negative 9 meter, and 20 times 8.85 times 10 to the negative 12 farad per meter times, no, that's it. This equals 2 times 10 to the negative 13 meter square. Okay, so that is area for each tiny capacitor.